So find the derivative of f of x equals square root of x. Well, we are going to begin with our definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. Well, evaluating, that is the limit as h goes to 0 of the square root of x plus h minus the square root of x over h. Now we need to rationalize this so we can get rid of those square roots there. That is our trick we keep pulling. So square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x, multiplying by a clever 1. All right, that will be the limit as h approaches 0 of x plus h. The outer and inner terms cancel, minus x over h times square root of x plus h plus square root of x. Several things cancel here. Our x terms cancel, and then our h divides out. So let's bring that up here. So this is the limit as h approaches 0 of 1 over square root of x plus h minus the square root of x. All right, now as h approaches 0, this is the function 1 over 2 square root x. Therefore, f prime of x equals 1 over 2 square root of x. Now, at some point we discussed finding the derivative at the point, I believe it was 4. And if you evaluate this at 4, you get 1/4, which is the slope we had gotten previously. So this is a function that will give you the value of the derivative of the slope of the tangent line at any point, as long as that function exists. So at 0, it does not exist. So we have to pull some limit trickery there to make that happen. All right, our next function, x squared minus 2x. So to find the derivative there, f of x, f prime of x, is the limit as h approaches 0. And you might recognize some of these functions from before because we did these before. We're doing it more generically now. So plugging in x plus h squared minus 2x plus h, minus f of x, that is x squared minus 2x. And I really should probably have that in brackets, divided by h. All right, well, multiplying some things out, x squared plus 2hx plus h squared minus 2x minus 2h minus x squared plus 2x all over h. All right, so taking that limit now, several terms should cancel out. In fact, every time we find a derivative function here, the slope function, everything that is on a part of f of x should cancel out. So in this case, the x squared cancels out, the 2x cancels out, and if you notice, an h factors out. I'm going to go ahead and factor an h out. That is 2x plus h minus 2 all over h. The h's then cancel out, and as we take the limit as h goes to 0, we get, well, I'll just go ahead and mark these out for posterity's sake. If we scratch these out, h goes to 0. This is 2x minus 2. So that is f prime of x is 2x minus 2. And if you look ahead a couple of videos and a couple of sections, there are some rules, so you might be able to see sort of a pattern that's happening here. Okay, let's move on to example 3. The derivative of x squared. This is going to be very similar to that last one. Let's throw in our limit. All right, that is f of x plus h. So this will be x plus h squared minus f of x over h. All right. Multiplying that out, we get an x squared, which will cancel out, plus 2hx plus h squared minus x squared over h. Well, if we cancel out our x squared terms and divide out the h, the limit as h goes to 0 of 2x plus h. And that limit is 2x. Therefore, f prime of x is 2x, and we can use that to find the slope of our tangent line.